Hey there, friends. This is Kevin from happycoding.io. And over the last few days or weeks or some amount of time, I've been going back and sort of updating the HTML and JavaScript tutorials. And I'm not quite done. I still need to finish up like jQuery Bootstrap, make those more legacy. And I have to finish up the Ajax and JSON, convert that to fetch instead of this old XML HTTP request. But for the most part, these are new and improved and updated. So I'm going to kind of celebrate that today by doing a sort of vanilla JavaScript HTML project. No P5, no jQuery, anything like that. Just kind of vanilla. And the project I want to do is one of my favorite, little games, I guess. And I'll get into why it's one of my favorite games as we get through the video. But it's called the Game of Nim. Game of Nim. You might also have heard this called like the Subtraction Game, but this guy, where you start at a number, generally like 21, and you take turns with somebody, and you can either subtract 1, 2, or 3, and you win if you leave the other player with 1. So, this is the section I'm thinking about. And it has some interesting properties that we'll get into, but I like it because the setup is relatively simple. It's basically just subtraction. So you start with 21 and you can subtract either 1, 2, or 3, and you take turns. So the project I want to do is to create a little web page that lets you play that game against the computer. All right, cool. So that's my goal. Let me just kind of dive in. I have not prepared anything at all for this, and so we'll fumble through it together. So the first thing I want to do is just create like a skeleton HTML JavaScript file, and I never quite remember the syntax for that off the top of my head, so I'm just going to steal it from somewhere. And that place I'm going to steal it from is my own website. So if you go to happycoding.io and look at the JavaScript tutorials, there's resources there that you can use. So I'm going to paste my content into my file, and I'm going to save it. And let's just save it to my desktop. All right, so I've got my index.html file, and so I can open that up in my browser. And there we go. We have the skeleton is up and running. So I can edit my file here, and I can view the output of my file in the browser. All right, cool. So let me think about this. Eventually I'm going to want like buttons and stuff, so I don't know, let me just get started and say like Game of Nim. So I might start with like some instructions, maybe something like this. So I'm trying to think of like how to write these instructions, and it's going to be hard to like type and talk at the same time. But I'm also going to want like a counter. So maybe I'll say like total, something like this. This will show the current value. And then I'm going to want some buttons. So I think what I'm going to do is I'm going to get the skeleton in place, and it's going to be super ugly, but that's fine. Button ID equals, actually, do I need an ID here? No, I just need kind of on clicks, I think. There's a few ways I could do this, but I think I'm going to use on click. Actually, let me not even bother with it yet. So I'm going to have like -1, -2, -3. So like subtract 1, subtract 2, or subtract 3. And just kind of check in, see what this looks like so far. Like I said, it's going to be pretty ugly. Actually, even just this is kind of fine. The idea being I'm going to subtract 1, 2, or 3 from this number, and then I'm going to have the computer subtract 1, 2, or 3 from that number, and that's how we're going to like implement the game. So I think think what I can do is just have on clicks here. Is it on click? I don't remember the capitalization, but this will either work or it won't, and I'll change it if it doesn't. So subtract 1, I'll say. That's the name of the function I'll call here. Button on click, subtract 1, 2, 3. And now I can define my functions up here. I thought maybe I would need to do like a body on load, but I actually think that I don't. I can just set the defaults in my HTML and then go from there. So let's see. So I'm going to need like the current total or the score, or whatever this number would be called. I don't know if they call it anything. Yeah, okay. I'm reading this now, and it's funny, like this is actually describing a slightly different game than what I was talking about. Maybe I should have read this Wikipedia article first, but the version of the game I play, you start at 21 and then you subtract. This one, you start at 1 and then go up. It's the same principle though. It's the same idea. Anyway, where was I? So I'm just trying to think of this stupid variable name. I'm just going to call it total for now. I might change this later. I might not. I'm bad at naming things, especially when I'm on mic, whatever. So we have the total, and then we're going to have some functions like function subtract 1. And these all are going to do something very similar. So I could have maybe made this given this like a parameter. Subtract 1, 2, or 3. Yeah, maybe let's try it this way. I think that'll work. We'll see. And I'll just call this like n. So I'll say total minus equals n, and then just to get something up and working, I want to say like document.get element by ID. The ID is going to be total, so it's this h tag dot text or inner text equals what? Equals the total. All right, let's just see what this does. So can I subtract 3? I can. Can I subtract 2? I can. Can I subtract 1? I can. And there's no gameplay yet. Like it'll just keep going negative, and that's fine, but everything's kind of connected. All right. So what I want to do is, so in a way, what I have is like the player turn is working. So now I want the computer to be able to take a turn. And the way I want to do that is let's say like computer take turn, or like play computer turn, something like that. Play computer turn. And what this is going to do is the computer is going to need to pick the number to choose. Like, and there are a few ways to do that, and I'll get into that in a bit. But for now, I think it's going to be kind of random. So actually what I'm going to do is say like if the total is less than what? If it's like 2, 3, or 4, then the computer can win. So if I'm at 2, then I know I need to subtract 1. If I'm at 3, I know I need to subtract 2. And if I'm at 4, I know I need to subtract 3. So what do I need to do? I need to subtract, let's do it this way maybe, subtract total minus 1, is that right? And my neighbors have decided that now it's a great time to move their furniture and possibly vacuum upstairs. So great. Sorry if that's annoying to you. I know it's annoying to me. But anyway, so that's like, this is like the winning case. Like this is the computer it realizes that it can win. Otherwise, I'm going to choose a random number between 1, 2, like out of 1, 2, and 3. And how do I want to do this? So what I want to do is, so maybe I'll put this in a variable choice, something like this, equals, so it needs to be at least 1. It needs to be at most 3. So I think I want to do like math.floor of math.random times 2 times 3. Let me see. If this is 2, then the highest this will get is 1. I think this should be 3. Well, let's just see. Actually, here's what I'm going to do. Since I don't quite remember exactly what this needs to be, here's what I'm going to do. I'm going to do something like right here, right at the beginning. I'm going to do something really dumb, but it'll help me think about the problem. I'm going to say I equals 0, I is less than 10, I plus plus, and in this for loop I'm going to do the thing. I'm doing this because I just want to see what the values are. All right, so let me refresh this. Let me bring up my console. So yeah, okay, it's 1, 2, 3, 2, 1. Yeah, all right, that seems to be right to me. Maybe let's just make this 100. Yeah, all right, that seems reasonable. Seems to be like randomly 1, 2, or 3. I think that looks right. Yeah, I'm fine with that. So my choice is correct, or correct enough for my purposes. And what do I want to do here? I want to do subtract choice, right? So I don't have like a notion in this function of who is playing, but maybe I'll add that in a second. Okay, so what will happen? When I run this, the player can subtract a number, and then the computer will want to subtract a number. So I think what I'm going to have to do is maybe split this. So like play computer turn, I need to be like subtract player choice, maybe like something like this. Function subtract player choice, and this needs to be choice, you know, something like this. Okay, and what do I want to do here? I want to do this down here, here, here. So this lets me kind of split up the logic so that I can do, yeah, what do I want to do? I want to do, yeah, let me split this out. So maybe I'll do like total minus equals n. Should I just do this same thing? I'm trying to think if I should extract some of this into a function, and I guess you know what, it doesn't really matter. Let me just do this, subtract choice. These variables names or these parameter names are a little goofy, but it's okay. So I'm going to subtract the choice, which will subtract from the total and will update the element, and then I need to play computer turn. Play computer turn. And what I might do is here, good enough. Let's just see what this does. All right, so I'm going to play 3, and so what I expect is for, so I'll subtract 3, it'll go to 18, and then the computer will make a choice, and it'll be a random number. So it'll be like between 15 and 17. Yeah, okay, so I chose 3, that made it 18. The computer chose 3, that made it 15. So same kind of deal. I chose 12. I chose 2. That made it 13. Computer chose 2. That made it 11. Yeah. Okay. This seems to be working. It's not quite a game yet because, well, a couple things. Like when I click this button, it just goes down by a number. It's not clear that there's a computer playing against me, and there's no win scenario. It'll always just, oh wait. Why did that happen? Oh, right. So I am subtracting 3, which makes it -2, and then the computer is playing -2 minus 1, which like makes it go back to 1. That's funny. The AI, this very advanced AI of a single if statement, is the only thing it knows is that it wants to reach 1. It does not know that like being negative is not a valid state. So that's really funny. It's like smart enough to go back to it, but not smart enough to understand that that's illegal anyway. It's like I'm playing, I don't know, checkers with chess pieces or something. Anyway, so there's a few things I want to do. I want to maybe make like a little log. And so what I'll do here is maybe I'll have like a div, something like this. And what do I want to do here? Maybe I'll make a P. And I'll say game starts at 21, something like that. All right, and then in here, I want to have like a log function or something that I could call them, and we'll see. Function, log, and then I want like a string message. And what this will do is we'll append to my HTML log. So what I want to do is something like document.get element by ID log dot what do I want to do? Dot inner HTML, is it capital, something like this, plus equals what? Maybe another P plus message plus P. This is kind of gross. There's probably a smarter way to do this, but whatever. I think this will work. So here I want to say like, so this is subtract player choice. So log something like human subtracts plus choice, something like that. And then what do I want to do? I want to do like new total maybe, or maybe I'll do that here. Log new total plus total. And I need one more, I think. I need that in the computer turn. I guess I could just put it in here. Here's what I want to do actually. I'm going to say like let choice, and then choice equals this if we know we're about to win, otherwise choice equals this. And that gives me like this ability to use this variable here instead of writing some code in both parts, in both the if and the else. So I can just say something like log computer subtracts plus choice here. Again, this is another, maybe some of this could have been a function. I don't know, this is fine. So let's just see what breaks. All right, so game starts at 21. Human subtracts 3, new total 18, computer subtracts 2. So why does that not say new total 16? Did I mess something up? Oh, well, yeah, that makes sense. I'm never actually subtracting it. So let's say subtract what, choice? So refresh, I'm going to choose 3, goes down to 18. Wait, game starts at 21, I subtract 3, the new total is 18. Something's in the wrong order. Oh, right. So I need to log the choice before I do the subtraction, because I then do the next log inside of that subtract function. Okay, I think this is going to work. Third or fourth or fifth time's the charm, right? All right, I'm at 21. I choose 1. That makes us at 20. Computer subtracts 2. That puts us at 18, and I can keep going. So I can say I choose 3. That puts me at 15. Computer subtracts 1. That puts us at 14, and we can keep going. And that's cool. It's going to go off the screen, but that's fine. I can style this, I guess. And eventually we'll reach like the negatives. Yeah. So this is what I was talking about earlier. So we're at 4. Computer subtracts 3, and so the computer would have won here, but I don't have that coded yet. So now I subtract 2, or I subtract 3, which takes us down to -2. And the computer is funny, and it's going to say, fine, I subtract -3, and that puts us at 1, and the computer is winning no matter what because of that little if statement at the very beginning. So the next thing I want to do is check for win conditions. So how do I want to do that? I could do that in the subtract function, but then in here I don't know whose turn it was. So I could like add a parameter here, but I think what I'll do is put that in here, maybe, like in the individual functions. Well, first of all, let me maybe take a step back and ask myself what I want to happen when someone wins. I want to, I think, just display like an end screen that says either you won or the computer won, and then like a reset button. And really, I mean, I could probably put the reset button. The reset button could be visible at all the time. We'll see. Button ID maybe. Let's just make it button first. See how we feel about it. Might do something with it. Might hide it. We'll see. Yeah, I don't hate that. And like we'd play, and then there'd be a reset button. That seems fine. I do think that while I'm staring at this, I'm going to make this a UL, maybe make these LI, and then make these LI. I might style them with some CSS or something, but I'm annoyed by how much space they're taking up. So yeah, it seems fine. Okay, so where was I? I was going to do a win screen. Okay, or win little display. So when we win, the player should not be able to pick any buttons, and we should display like a message. So first of all, let me do the message part. So subtract player choice, we do subtract, and then we play computer turn. So here's what I'll do, like if total equals 1, then what do I want to do? I want to do something, and I only want to play the computer turn if that's not true. So I could probably do like a return or something, like a guard clause, but this is fine for now. If total equals 1 after the player has chosen, then I can log like you won, log you won. And what else do I want to do? I want to disable the buttons maybe, but let me cross one bridge at a time. So player turn. So after I do the subtract here, I want something very similar to this. So after the computer subtracts their choice, if it's 1, then computer won. Okay, and at that point I should also like disable these buttons, maybe show this reset button. Yeah, that's probably the right thing to do. But first off, let's just check that logic works. So I'm just going to subtract 3 a bunch of times to make this game a little faster. Down to 9, I'm down to, okay, so here we go. So we were at 9, I subtracted 3, that put us at 6. The computer subtracted 3, which put us at 3. So we're at 3 right now. So if I subtract 2, I will win. And that did work, cool. Reset doesn't actually do anything, so let's refresh. Let me let the computer win this time. So yeah, it's fine. So we're at 4. If I subtracted 3 right now, I would win, but I want to subtract 1 instead and let the computer win. And that worked, cool. So then what do I want? I want to disable these buttons. So maybe what I'll say is something like function disable buttons, or maybe set buttons enabled. When am I going to re-enable them? Yeah, I'm going to re-enable them when I click reset. So function set buttons enabled. And let me think about this. So I could just do, like, I could just add IDs to them. I could add a class to them. I could then call it get elements by class. Yeah, let me do it that way. Class equals player button, something like this. And that will let me use the handy const, let's see, player buttons equals document.get elements by class. Player button? I never remember quite the syntax, so I could look this up. By class name. Okay, that's right. So I want this. Yeah, so that'll give me an array, or technically it's like an array-like object or something. JavaScript is super weird. Whoops. It's an HTML collection, so it's kind of like an array. I don't know. It doesn't matter. It's close enough to an array that it'll work. So what do I want to do? I want to loop over these. So like for const button of player buttons. And then I want to disable it. So I want to say something like, is it CSS, or is it like button dot disabled? It's something like this, equals not enabled. It's kind of goofy. Maybe I should have made this disabled instead of inverting it, but whatever. Button dot disabled. Sure. I'm guessing that something in here will not work, but we'll see. We'll cross that bridge. And when do I want to do this? So I want to call this when someone wins. So here, and here. So now when someone wins, the buttons should get disabled, or something will break horribly is more likely. So let's just play. Did that work? Oh, cool. That worked. That actually worked. These are disabled now. Nice. I'm actually pleasantly surprised by that. I really expected that to break. Cool. So then the other thing I want to do is say like on click here equals reset. So this will let us reset our game. And so I've got these functions. I might rearrange these. It's fine. So I'll say function reset here. And what will this do? This will do a few things. This will say set buttons enabled to true. So it'll re-enable them. It will also say total equals 21. And the other thing it needs to do is clear out the log. So let's see. What I can do first. Yeah, okay. So I'll do something like this, where I get the inner HTML and I just reset it. So I could just set it to empty here to clear it out, but actually what I want is this guy. Okay. And then I will log, wait, no, that's actually fine. That's all I need. I could have set it to blank and then logged this, but this is fine. Yeah, I'm debating which one is a little bit cleaner. I actually think I want to log it. Let's do it that way. So inner HTML equals empty, that's fine. Then I'm going to log that. Good enough. And let's test it out. Let's see. So a couple things. First of all, I can probably click this at any time. Well, sort of. Okay, good, fair enough. Good thing I tested that. So total equals 21. I also need to change that that element here, I guess. I might think about the order of this. Actually, I think I'm going to do it this way. Yeah, I don't know why, but in my brain, it's a little bit more logical for the buttons to be enabled last. So when I call reset, what am I going to do? I'm going to say total is 21. I'm going to reset the element here. I'm going to reset the log. I'm going to add something to the log, and then I'm going to enable the buttons. It doesn't actually matter because all of this will happen sort of in the same, I don't know, frame or whatever the word is, but it's not like the user will see that there was an order, but I don't know, in my brain, that's a better order. Okay, so I can reset this at any time. Yeah, okay. We'll see. I might keep that in, I might not. Probably won't actually. All right, but let's look at the end game here. So I'm going to subtract 3 and put us at 5. Computer will not be able to win yet, and we'll make another choice, and we'll see where we go. So all right, we're at 2. So there's actually, like, I have to win. I can either win, or I will go into an illegal state. So another thing I need to do is like not let the player go into an illegal state. And so it's fine, whatever. I'm going to hit -1 here, and so what should happen is this should go to 1. I should get the little message down at the bottom, and my buttons should be disabled. You won. Yeah, cool. I think maybe this should actually go up here or something, but here's what I want to test. When I reset this, the buttons should be enabled again. And they are. Cool. So this works pretty well. The one thing I want to do is, like I said, I want to prevent the user from getting into these illegal states. So 6, 2, 1. Yeah, okay. Actually, no, that's not what I wanted. I'm trying to get back into the state where it's, here we go. Here's one. So I should not be allowed to subtract 3 at this point. So I actually am going to need to put IDs on those buttons after all. Oh well. There's probably a hacky way to do it. It's like with like array indexes or something, but it's probably gross. So how do I want to do that? All right, so first off, it's kind of gross that I have like both a class and an ID, but it's fine. One button, and this formatting is kind of yucky, so let's fix that a little bit. Maybe that, sure. And ID equals 2 button. ID equals 3 button. Again, I don't know if you can hear my neighbors, but they have decided that they are like racing like through their apartment. I admire their exercise regime, but it is super distracting. I think I just got new upstairs neighbors, so hello, new upstairs neighbors. All right, so I gave these buttons IDs, and now I can sort of enable and disable them when I need to. So when do I need to do this? This is going to get a little messy. So I need to check for, I need to do this no matter whose turn it is, or no matter whose turn just happened. So I'm going to call it from subtract. I'm going to maybe make a new function that's like set. I already have set buttons enabled down here. It's going to be like, I don't know, check button enabled, or like disable illegal buttons, or yeah, let's go with that. Illegal buttons. It's kind of a goofy function name, but that's okay. So maybe I'll put that here. Kind of group the functions that are related to the buttons together. Function disable illegal buttons. And so what do I want to do here? I want to say if total is less than or equal to 3. Actually, here's what I can do. Because there's really only 2. There's only a couple cases actually that this impacts. So it's like if total, let me just think about it this way. If total is 1, first of all, if total is 1, then the game has ended. So this is never going to happen. So I don't have to worry about it. All of the buttons will be disabled when total is 1, because we already check for that somewhere else, which might indicate that maybe I should move this code somewhere closer to that, but it's fine. So next I'll say like if total is 2, Then what I want to do is disable the 2 and 3. Yes. All right. So how do I want to do that? I want to say document.getElement by ID and 2 button and 3 button. Dot disabled equals true, and I want to do the same thing for the 3 button. Yeah. So if it's 2, really the only choice you have is to pick 1. Yeah. 3 button dot disabled, and similar thing if total is 3. So if total is 3, then I only want to disable the 3 button, and I think I'm going to find a pattern here, but let me just think through this in kind of a dumb way first. So it's actually going to be pretty much this exact same thing with a 3 here, and this is not here anymore. So if it's 3, then you can either choose 1 or 2. If you choose 1, then you're going to lose, but it's still a valid choice. So there's probably a smarter way to do this. I think probably maybe like with a greater than here. Hold on, let me think about this. So if it's 2, then I'm going to do both. So I mean, I'm sure there's a smarter way to do this, but I kind of don't care. I like this. This is fine, I think, for my purposes. Like, sure, I have this one repeated line of code, and I think the way I can do that actually is if I do this, then I don't need that. But I actually think that's harder to understand than just this more explicit version. So I actually think I want to keep it this kind of dumb way. Yeah, I think I am, because this is easier to read, and I think that's more important than trying to be clever and make sure that like this one little line of code is not repeated. I think repeating it is actually more understandable. So I know, like, don't repeat yourself is this old like programming, I don't know, principle that people throw around, but it's more like repeat yourself sometimes. Repeat yourself when it makes sense to repeat yourself. Whatever, I'm rambling. So let's play. We're at 12, we're at 8, so we're at 4 now. So I mean, the computer's going to win, but that's fine. Reset, let's try again. Yeah, computer's going to win again. Actually, I won. Okay, fine. I could probably hard code to get myself into a better situation, but whatever. So what do I want to do? I want to do -1 here. Yeah, okay. So, oh yeah, good. So see, this 3 is disabled, which is exactly what I wanted. And so if I hit 2, then I'm going to win. Cool. So I'm at 6. If I subtract -2, then we'll be at 4, and the computer will win. Is that right? Yes, the computer will win if we're at 4 because it will subtract 3. So I'm going to subtract 1 and put it at 5, so it will not have a good choice. Yeah, cool. That was perfect, actually. So now I see -2 and -3. They are disabled, exactly how I would expect, and I can only choose 1 here. And I win. Perfect. Cool, and I can reset, and this is actually pretty good. I mean, this is a full game. It's working. I'm not able to get into any illegal states, and so from here on out, I think it's more like improvements. And let me see where I am at time. 40 minutes. These always go longer than I plan. Whatever. So let's see, a couple things I want to do. First of all, I think I want to get rid of this reset button, at least by default. So what do I want to do here? I want to say like ID equals reset button, And maybe let's add some CSS. So should that be before or after script? It doesn't matter. Let me put it here. I could probably put these in their own files. In fact, I should probably put these in their own files, but for something like this where it's straight up like one page, I'm okay with putting it in one single file like this. And I call it reset button. And what do I want to do? I want to set its visibility, and I think there's a few ways to do that, but I'm going to say like display none. And then what do I want to do? So first I want to refresh and make sure it's not there. Cool. And I want to make it visible again somewhere. Where? So I have these, so set buttons enabled. False. I could set it here. I'm going to have it in two places, like once in play computer turn, once in subtract player choice, and maybe that's okay. We'll see. So document.get element by ID, reset button dot style dot display, something like this equals probably like inline block or just block. It doesn't matter. We'll figure it out. So this is setting the button to be visible again. I could maybe have put this in its own function, like along with some of these other things, like maybe set buttons enabled false and hiding or showing the reset button. Maybe those go in the same function, but this is okay. And then I need one more thing. I need to set it back to invisible when we reset, actually. So here, yeah, this is fine, equals none. All right, so refresh. So when someone wins, the reset button should display. Cool. When I click this, it should clear, it should go back to the start state, and the reset button should go away. It does. Cool. Let me see if I can win. So we're at 7. If I go to -3, then the computer will be at 4 and the computer will win. So let me put them at 5. And reset button shows up. Cool. All right, nice. I'm debating whether I want to put this U1 somewhere, like maybe up here. I think that's probably easy enough. Let's try that. So where do I log like U1 or computer 1? And also let me steal this code while I'm here. Couple things I could do. Couple things. Let's try a couple options. One thing I could do. So where do I call this? Computer 1. Since this is HTML, I could do something like this. This might be gross. This might. I don't know what an LI that contains an H2 is going to end up looking like. But let's just see. I can't tell if I hate it or not. I think it's kind of fine, actually. I might change this style. What's this style? Computer 1. Go away. I think it's like it's margin top and bottom. So what if I say like margin 0? Okay. That's not bad. Yeah, okay, let's do it that way. I thought maybe I would put it up here, but I kind of like it down here because it kind of tells the story a little bit better. But let me maybe add a style for this. So what is this? This is real goofy. This is going to be like it's LIH2. That's a really funny like if you're like a real web developer and you're cringing at this, like that's all right. I'm cringing at it too. but whatever, it works. What did I want to do? Margin 0 here. Yeah, cool. So now it's like very obvious, but it's not super spaced out, super gross looking. And then the reset button's down here. Nice. Okay. Let's see. So a couple things. Let me try to make this like a long game. So what's this end up looking like? I think it's okay. I think maybe I could put this in a div and give like a max height and show like the like a scroll bar, but I think it's fine. I'm trying to think of how I'm going to embed this, because I'll eventually like put this up on Happy Coding and it'll show up in an example. And I haven't looked at these in a long time. Ew, gross, I don't like how I did this. I'll probably go back and change this a little bit, but it'll end up looking like this, where it's like embedded somehow. I think it's fine. I'm not going to worry about it. I think it's okay to have this scroll bar show up. Yeah, whatever. So there's a couple things that I could do. One thing is, like right now, when I hit a button, the computer plays like right away. And because the math is so, there's nothing, the computer's not thinking very hard. So it happens right away, which is a little bit like, I don't know the word for it, but like it breaks the illusion of the computer taking a turn. So I could introduce like a timeout. So like maybe if I hit -3, I'll say, human subtracts 3, new total, and then like something like computer is thinking ... and then I'll wait a second, and then I'll subtract a number. Yeah, you know what? It's Sunday afternoon. This might end up going for 3 hours, but that's all right, right? If you've watched this far, then you're here for the duration, I'm guessing. So let's see, how do I want to do that? So after the player choice happens, yeah, okay. So play computer turn. What I actually want to do is set a timeout. Set timeout of, I don't know, like a second maybe. That might end up being too long. And play computer turn will be like a reference or whatever that's called, like a callback. I'm almost definitely going to forget the syntax for this. What did I just say? Timeout window. Yeah, this thing. The function comes first and then the number. Yeah, okay. So function, so set a timeout, play computer turn. Oh yeah, I guess that kind of makes more sense anyway. Like 1000, and actually I'm going to do this. So actually I can do that up here. So no matter what, I'm going to disable the player buttons, whether they've won or not, because I don't want the player to like be able to go twice in a row. And set timeout, play computer turn. So let me log something here maybe. Computer is thinking. It's like definitely just fake, but I'm hoping that it makes it feel a little bit more like a like a game, rather than just clicking a button and random stuff happens. So all right, I have set timeout, play computer turn. So a second after I make my choice, the play computer turn function will be called. And then, yeah, everything else will stay the same, except here, if the computer has not won, then I need to set my buttons to be enabled. Yeah, here. All right. I'm sure that I just broke something, but let's just see. So nothing super obvious. So I'm going to hit 3 and the computer will start thinking. Let's see what this feels like. Ooh, I didn't hate that. I think that's kind of fine. So, oh, and wait, but my buttons are not enabled. Computer is cheating. Computer is not letting me play. That's rude. And what did I do? I'm sure I did something dumb. Play computer, turn. Oh, yeah, duh. True. All right, so I always start with 3. Let's switch it up. Let's start at 1. Yeah, okay. You know, if I was feeling real fancy, maybe I would kind of animate this a little bit more so that you don't have to like look down in here to see exactly what's happening. Like maybe the -3 comes in and like animates and changes the number, but I think it's fine. So yeah, okay, that feels a little bit more like a game. I could maybe pop up like a little image of a computer thinking or something, but whatever, it's getting a little silly. So I'm at 8, and so if I subtract 3, the computer will be at 5, and the computer will be screwed. So let's try that. Yeah, cool. So now, oh, wait, this is not right. Something's broken here. So I'm at 3, so I should not be able to subtract 3. Why is this enabled? Oh, you know why? Okay, so I'm setting the buttons enabled here to true every time, but that's after crap. So I call subtract up here, which disables the illegal buttons. So it disabled the -3, but then I say set buttons enabled to true here. Ah, it's gross. I mean, a couple ways to do this. I mean, I could just... Ah, man, it's yucky. I could just move this up. That's yucky. It's yucky. I could move it up to here so that I enable the buttons and then I subtract. And then in subtract, it will disable the illegal buttons. It's kind of gross just because we were kind of going back and forth. Like, I enable the buttons, then I disable the buttons, then I disable them here in the case that where we won. But I can get rid of this else. I don't know. This is where it gets kind of subjective. Like the code, you know, all of this will do the same thing, but something about this feels gross to me, which doesn't really matter, I guess, especially because, you know, I'm not going to hand this code to a team member or anything. I'm just going to post it as the example. Although, you know, then other people are looking at it, so maybe I do want to think harder about this. So set buttons enabled to true sets them all to enabled. Maybe what I should do is in set buttons enabled, if it's true, then I actually check. No, you know what I'm going to do? I think what I'm going to do, let's see how we feel about this. So in set buttons enabled, true, I'm wondering if I can just call this function from this function. Would that clean it up at all? So I say set buttons enabled, and if it's true, actually no matter what, because if it's false, then it doesn't really matter. So how do we feel about this? So then I no longer need what? I no longer need this. Is that right? No, I do need that. Duh. Actually, I need to go back. Oh man, this is getting really gross. Whoops. I think I'm just going in circles now, and this is the kind of thing that you can go down a rabbit hole and just like think too hard about like exactly how you structure your code, and in the end it doesn't actually matter. So let me just think about this for a second. So when I subtract the player choice, we say subtract, which will disable the illegal buttons. Fine. Actually, I don't need this here anymore, do I? Probably not. Not with your current code. No, whatever, just keep it. So this is like approaching where the code is getting just a little bit too long to just keep in my brain all at once. So let me just read through this. So when I subtract a player choice, I log it, I subtract it, which subtracts from the total, updates the element, logs it, and then disables the illegal buttons. And that's because when you subtract it and you get down into 3, 2, then you want that to happen. Fine. Then I say set buttons enabled false because I want to disallow the user from just like spamming one of the buttons while the computer is thinking. And then in set buttons enabled false, I'm calling disable illegal buttons again, which is kind of gross because like I just called it actually, but maybe it's fine. And then I say computer is thinking. I mean, sometimes you won, but that's the less interesting case. Log computer is thinking, and then after a second, play computer turn. Play computer turn comes up with his choice, logs it, subtracts it. This is where we get back into disable illegal buttons, and then either the computer won and I hide or I disable all of the buttons, or it's now the player's choice and I set buttons enabled to true, and that's when I want to disable illegal buttons again. So you know what I am going to do? I am going to say like if enabled. That's slightly less gross because then I'm not calling disable illegal buttons like multiple times in a row unnecessarily. It's still a little gross, but it's less gross. Anyway, all of that was just me like rambling about like what order I should call functions in instead of actually getting anything done. So none of that actually matters, but whatever. All right, let's play a game. Okay, cool, that worked. We're at 17, I subtract 3, computer thinks. We're at 12, let's just go until we're down into the interesting numbers, and here we go. So I'm at 6, if I play 1, then I will eventually win. If I say 2, then the computer will be at 4 and it'll subtract 3 and it will win. If I subtract 3, then the computer will be at 3 and it'll subtract 2 and it will win. So let's say, do I want to be nice or not? Let's be nice. Yeah, okay. Cool, that worked, and cool, reset, that seems fine. All right, so actually what I want to test is the sort of illegal state. So I'm at 12, and it's fine. We're at 6. All right, so let me be a little bit mean. Let me say computer force that to be at 5. It'll choose a random number, and we're at 2, and that worked. My 2 and 3 are disabled. Nice. All right, that's fine. Oh, we can't right-click a disable button. That's dumb. And what do I want to do here? I want it to be like font size equals, I don't know, 24 pix. I never remember which one you're supposed to use. Let's say pixel. So what's a good number here? 24 looks pretty good actually. Yeah, let's go with 24. Let's add that style. Okay, so I've got my reset button, and what do I want? I want my player buttons to have their own style. What did I call them? Player button? Yeah, player button. Font size 24 pix. Maybe. Sure. Okay. And let's see, a couple of things I might want to do. So this is getting pretty good. Yeah, computer's thinking. Okay, that's funny. We're at 13, we're at 11, we're at 10, and so if I put it down to -3, we'll be at 7. Computer won't necessarily win. Okay, so I could win by subtracting -3. Computer could win if I subtract 1 or 2, because it's too smart. Doesn't matter, let's just see. Okay. Okay, yeah. Another thing I could do is maybe like some of this expires, you know, like you probably only really care about the last couple of moves, but nah, it's fine. I'm not gonna worry too much about it. And reset, reset's fine. Okay. So that's pretty close to like a complete game. One thing I do want to do is maybe just explain the rules at some point. So maybe here I'll do something. So I'll say like P, maybe I'll hide this eventually. ID equals instructions, something like that. And what I'll say is game starts at 21, take turns subtracting 1, 2, or 3. Win by leaving your opponent with 1. I don't know, something like this. What's this look like? Game starts at 21, take turns subtracting 1, 2, or 3. Win by leaving your opponent with 1. Yeah, okay. Maybe this should go away after the first player choice. Maybe. So what did I call this? Instructions. So here, maybe here, let's just see what this feels like. Document.get element by ID, instructions dot what? Dot style dot display equals none. Similar to what we did before with the reset button. So now the instructions are there, and then, you know, I'll read them and I'll click something and they'll go away because presumably I've read them and I don't need to keep reading them. Okay, I mean, that's fine. I don't love that it kind of jumps. I could maybe just make this always there. I could maybe put it at the bottom. I could maybe make this the like this here. Maybe. Let's try that actually. So how did I do that? I did that here. So I did that here, and I also would do it in the reset, but let's just see what this feels like. And what I'm gonna do, maybe just comment this out. Wait, no, not that. This up here. Here's what I'll do. I'll say like style equals display none, just to get rid of it for now, but everything else will still work. Fine. Okay, this seems fine. Yeah. Okay, I actually like that. That's fine. I could maybe split this up even. Nah, it's fine. So let's just play a game. Computer thinks. It's funny, when I just want to play through a game, I get like annoyed that the computer is taking too long to think. And if I reset, then yeah, I could change this again. It's a little gross that it's I'm copy pasting the same thing in a couple places, but that's life. That's fine. Okay, good enough. Could maybe put a line break in there or something, but it's fine. Actually, you know what? I'm going to be picky. I'm going to be really annoying here. I actually am going to do that. Just because I was thinking about doing it before, and now I have another reason to do it, just to break up that stupid line break. So it's fine. I'm also just kind of procrastinating because I know that the next thing I want to talk about is going to be hard. Yeah. But it's going to be fun too. So I'll stop procrastinating in just a second. 1, 2, or 3. Yep. Whoops, log. Yeah. Okay. Fine. let's stop messing around here. This is fine. Game starts at 21. Take turns subtracting 1, 2, or 3. Win by leaving your opponent with 1. Yeah. I can keep playing. I can keep playing. Keep playing. So I'm at 8. If I go down to 3, the computer will lose, right? Yeah, okay. So 3, you won. And it's kind of dumb that the reset button's like just off the screen. Don't love that. But it's fine. Reset, reset, works. Okay, cool. So, all right, we're an hour into this video that I thought would maybe take me a half hour, but again, it's Sunday afternoon, so we're just going to have fun with it. So I'm going to call this kind of done. This is a random AI. Like AI is a very grandiose term to use in this case because the AI is literally this if statement. So the computer, the only smart thing it does is if you're at so that you win by leaving your computer with your opponent with 1. And so if you're at 3, it's not smart to choose 1 because you know that your opponent will win. So if we're at 3 and I choose 1, that leaves us with 2, and the only thing that the opponent can do is choose 1 and they win. And so that's what this part of the if statement is doing. It's just saying, like, don't choose a value that you know will force you to lose. And so the game only really gets kind of interesting when we're down into the values that are less than 5, so 2, 3, 4, because of that kind of property. So that's why I know when I'm in like 5, 6, 7, when we're in this range, I actually know the outcome of the game, because if I choose 1 here, then there's nothing. So let me start with 3. If I choose 3 here, I know the computer will win because I'm going to give them 3 and they'll subtract 2. And if I subtract 2, I leave them with 4, they'll subtract 3 and they'll win. If I subtract 1, I'll leave them with 5, and there's no number they can subtract that will win. And so it'll just like go forward by a turn, and we'll do the same thing again. So I can model that. And so here I'm at 2, and there's only one thing I can do. I can only win here. But the rest of the game is just random. The rest of the player or the computer choices are random, and that's fine. I could stop right here, and this would be a fully functional little game. But the reason I like this game specifically is that from here, you can do a whole lot of really interesting things and really advanced things too. So, for example, so once we get down to these lower numbers, it's kind of, you can reason about it. And you can say, okay, we're at 6, so if I choose 1, we'll be at 5. And then if the computer chooses 1, 2, or 3, here's what happens. You can do this kind of like branching logic tree. So like a decision tree, or there's an algorithm called Minimax that, I'm not sure if Minimax exactly applies here because, what are you minimizing and maximizing for? But you would kind of take turns, like mentally thinking about what would happen at each step. So, you can do that pretty reasonably at these lower numbers, like 6. It's a little harder to do that starting at 21, but the computer, computers can do that. Computers, they can crunch numbers. And so the computer, you could write a program that analyzes what will happen at each step. So let's say I subtract 1. I gave the computer 20, and what the computer can do is say, okay, I'm at 20. If I choose -1, that puts us at 19, and then it can like guess at what the human will do, and it will do that by saying, okay, if the human was at 19, they could choose either -1, -2, -3, and go back and forth. And the sort of Minimax algorithm is like you're trying to minimize your opponent's gain and you're maximizing your gain, or you're maximizing your chances of winning. So you could do that, and there's some interesting algorithm, interesting ways to approach that get pretty complex, but they're doable. We could code that here. It would be a longer video, but we could do that, and that would be pretty interesting. Another thing we could do is, I don't know the word for this, but it kind of models the way humans think about this game a little bit more closely. So the thing I just said is more of like the way a computer thinks in terms of like trees and taking turns and like this Minimax algorithm. This, like a human would not start at 19 and be like, okay, well, if I choose -1 here, then the opponent will choose that, and if they choose that, then I'll choose this, and if I choose, that's too much for a human to think in terms of. So instead, what will happen is, if you play this game against someone who has never played it, like, they'll notice certain patterns. And by that, I mean, once we get down to these bottom numbers, I've kind of already explained like what happens down here, but if you play this game with someone who has never played it before, they'll learn pretty quickly that, hey, if I have 3, then, well, 3 is a bad example because 3 is one of these like trivial cases where you can always win. But that's actually not a bad place to start. So I know that if I'm at 2, then I'm going to win. I know that if I'm at 3, then I'm going to win because I can subtract 2. And I know that if I'm at 4, I can win, right? Because I can subtract 3 and I leave the opponent with 1. If you play enough times, you'll recognize that 5 is a losing number. So let me see if I can get the computer to give me 5. It's all random. Let's just try. Whatever. So so we're at 6 now. If I choose 1 here, that I'll leave the computer with 5, and the computer can't win from there unless I mess up in the last turn. But the computer can't win if I give it 5, because if it subtracts 1, 2, or 3, that gives me one of the like trivial winning numbers. So it'll leave me with 2, 3, or 4, no matter what it does. And so humans will start to notice that pattern, but and the way you might codify that, or the way you might write that in code, is something like an array, like say from 0 to 21, or 0 to 20, I guess, with 0 indexes. I don't know, from 1 to 21. You code each number into as an array index, and whenever you win a game, you add some value to all of the numbers that the winner had, and you maybe subtract a number from the numbers that the loser had. And so if you do that over the course of multiple games, then what you have is this kind of weighted array of like the value of different numbers. And so we know that, for example, 5 is a losing number. But what about 6? Is 6 a losing number? And the answer is what? What is the answer? I actually don't know. The answer is that it depends. So if I'm at 6, it depends on what I choose here, right? So if I'm at 6, then I can choose -1, and that'll put it at 5. So what you end up with this is an array of each number and each choice at that number. So if I'm at 6 and I choose 1, then I'm going to win because of all the reasons I just outlined. And a human that you're playing against will eventually catch on to the fact that, hey, whenever we're at 6, I know that the other person always chooses 1, and I always seem to lose when that happens. So even though they might not even understand why that's happening, they will kind of just copy that behavior. they'll pattern match, and they'll say, based on the fact that this is 6 and the fact that the last game when it was 6 my opponent chose 1 and they won, I'm going to choose 1. And the answer is because of the way that the math works out, that's the right thing to do. But that kind of matches the way like a new person to this game would think about it. And you can code that up, and that would be another interesting kind of artificial intelligence project. It would take some amount of time. It would take a couple hours, maybe an hour or two, but it would be doable. It would be maybe just a different video. And that the reason I like that is that even though it's this simple game, you're modeling a few different ways to think about the problem and a few different ways that you can codify the problem, either in terms of like this tree approach where it's like this Minimax thing, or this more like pattern matchy, like weighted choices array. They're both valid. But spoiler alert, and if you want to like play this game a few times before I kind of spoil it for you, then maybe I'll recommend like pausing the video here, because there's actually kind of a trick to this game that you can use to like be like a perfect player, basically. So it's kind of like tic-tac-toe in that it's a solved game. A perfect player will never lose this game. And I did not look up what that trick is ahead of time. So, oh man, we're going to have to kind of think about it. And I know that this, like the visual aspect of this video is kind of boring because I've just been on this same screen for a while, but I find this stuff really fascinating. So how to explain it? So we talked about a couple different ways of thinking about modeling the problem, either with like that tree where you try to take turns in your brain of like modeling what each person or each player will do. We talked about like an array of the choices for each number and weighing those, but there's actually like a simpler, metric or heuristic that you can use that skips over all of that. So we know that, for example, if I subtract 1 here and I give the computer 5, I know I'm going to win, because no matter what the computer chooses, I will be left with a choice that makes me win. And so, in a way, you can think about it as like the point of the game is not to leave your computer with 1. The point of the game is actually to leave the opponent with 5, right? So my only goal here is to get to 5 now. So I'm just going to play for a little bit to just get us down to the interesting numbers. And well, here's a good example. Like the computer got to 5, and so no matter what I do here, the computer is going to win. Because if I choose 1, then the computer can choose 3. If I choose 2, the computer can choose 2. If I choose 3, the computer can choose 1. So computer's going to win. So let's keep going until I can trick the computer. Like the very start of this is random, so it's kind of up to the computer's random choice whether I can kind of trick it into letting me give it 5. Yeah, okay. So I'm at 6. So if I give the computer 5, then I will win. And so you can kind of sort of apply that pattern. So it's 1 is the real winning scenario, but 5 is the like next step up. And so now you think about the same kind of pattern. So what I really want to do is force the computer to give me a number that lets me give them 5. So I want the computer to give me either 6, 7, or 8. So that means I want to give the computer 9. So you might notice the pattern, like it's 1, 5, 9, and that sort of applies. So it's 1, 5, 9. So you add 4 each time. So 13, 17, 21. So what I want to do, so I'm at 21, so this is actually like I will have won. Is that right? I will have lost. Let's see. Oh wait, no, yeah, I would have. The computer will win. Hold on, I gotta think about this one. So it's 1, 5, 9, 13, 17. So I wanted to give the computer 17. So if I give the computer 17, yeah, okay, so there's nothing the computer can do that will prevent me from making it be 13. Same thing for 9. Same thing for 5. Yeah, okay. So it's actually, okay, yeah, I'm vaguely remembering this. Yeah, okay. I was confused for a second because like 21 seemed significant. And that's because the way this game works, so you've seen the pattern for the sort of winning numbers. The winning numbers are like 1, 5, 9, 13, 17, 21. So if I give my opponent one of those numbers, then I will win. If I give my computer that one of those numbers, I will win. The problem is that the game starts at 21, and I have made it so that the computer or that the human goes first. And so if the computer was smart enough, this would be impossible to win. So the only reason that I can kind of trick the computer into letting me give them 17 is like up to randomness. So yeah, it's because these numbers are random. But if the computer was smarter, it would never lose. And so what I want to do next is code that up. And I want to codify that a little bit. And so what I'll do is maybe make it a setting, maybe make it like a radio button. So maybe I'll put it up here, maybe something like, I never remember syntax for radio buttons, like HTML radio button group. Is that something? And it's kind of gross. Sure, I think it's based on the name. So I only want one thing to be selectable. I want like a mode, basically. So easy or hard mode. So how smart is the computer? Right now we're on easy mode because the computer is just random. So yeah, this is kind of yucky, but whatever. Let's steal some of this code and put that in our HTML. I don't know, here. We can always move it. So this label is kind of dumb. I'll put it. I don't like the label 4. I like this a little bit better. It's kind of goofy, but also I don't love that their example is gender. Then maybe let's go with a better example for selectable traits. Come on, guys. Anyway, sorry. Type equals radio. ID equals doesn't matter, I don't think, at this point. Actually, it will. ID equals easy, and name equals mode. And let's do easy. And BR, sure. Why not? So let me maybe, no, it's actually fine. Okay. Okay, hard mode value. I don't think I need a value actually, do I? We'll see. Let's just see what this does. Yeah, okay. Yeah, okay, good. I might put it up here. Easy, hard. Where do I want to put this? Maybe down at the bottom. Yeah, okay. Let's do a couple things. Let's say, what do I got? I got my CSS is not in any particular order, I guess. It's kind of gross, but It's fine. So maybe I'll make my total, my heading there. Maybe this thing should be display what? Inline block maybe? I could probably do some flex stuff here, but oh gross. What the heck? That's not what I wanted. Oh, that's because I didn't want the total. Duh. I wanted this thing, which does not even have an ID. ID equals title. It's goofy. Title. Yeah, fine. And maybe I'll put this in a div. Again, this probably should have been flex. Maybe I'll change it to flex. Yeah, let's change it to flex. So that means what? Means indent these. That means put this in a div. Div ID equals title and mode. Whatever. And fine. All of that just to do, well, just to spell stuff wrong. Title and mode, display, flex. Is that right? Flex box, flex, I never remember. Yeah, good enough. Kind of goofy, but, and I want like vertical align or something. Vertical align center, middle. Nope, that's not right. How do I align them to like the align children or something? Align items, center, E. That's not bad. Okay, yeah. Okay, I don't hate that. So let's do display flex, align items, center. Is that what I just did? Center, middle. I never remember. Center, yeah. And let's maybe give my let's do title and mode, each one, let's give that just a little bit of a margin. $25 maybe, something like that. Yeah, good enough. I don't hate that. Game of Nim, easy hard, sure. And how do I select a radio button? It's probably an attribute of some kind. Value? No. Is it just selected equals true? Probably. No. Selected equals, does this need to be a string? Something like this? No. All right, let's stop just guessing. HTML radio selected, yeah. Checked, that's what it is. That's just funny. Checked, yeah, right. Checked, okay. Fine, all of this just to give me this little radio button selector. Okay, easy or hard, fine, okay. And all of that to what? To do what? Let me maybe, I don't actually think I need both of these to have an ID, but we'll see in a second. And of course, it's kind of gross, whatever. Probably a few different ways to do this, actually. Let's do it this way. Sure. Okay, whatever. I'm going to stop messing around with just formatting things. All right, what do I want to do? I want to, in the computer turn, so right now, this is our in big quotation marks, AI. It's just random. So what I want to do is what? Is if, so I want to check on easy mode or hard mode. Let's check on hard mode. So if document.getElement by ID, hard mode dot checked, is that right? We'll see. Then do hard mode, which we haven't actually defined yet. Otherwise, do easy mode. And just to check, here's what I'm going to do. I'm going to say, whatever. Here I'm going to say choice equals 1. Just for now, I'm going to say console.log hard mode here, just to check that this thing actually works. And maybe here I'll say console.log easy mode. I could probably just look this up, but I would not even trust it anyway. So I'd have to test it no matter what. So this should say easy mode. Nope. Cool. Great. Actually, wait, it did print out easy mode. So subtract player choice, HTML 27. Oh, instructions. Oh, wait. That, I guess this line has been throwing an error for a long time. I just haven't been noticing, haven't been paying attention. So I can get rid of that because I've moved my instructions down into the log here. So fine. Refresh. So it's on easy mode, so I should see it say easy mode. Easy mode. Should say easy mode again. It did. Now I switch to hard mode. Should say hard mode. And it did. All right, cool. So that actually does work how I was hoping it would. Okay, fine. And what I want to do is in here, here's the magic. So we know the number that we want to give is 5, 9, 13, 21. It's these kinds of numbers. And what are these kinds of numbers? These are, so there's a couple ways to look at them. They are either like you start at 1 and you increase by 4. And the reason for that is like, since you know the sort of target numbers, so like 1 is the target, 5 is the target. The reason 5 works is no matter what if you leave your opponent with 5, then you can choose whatever number adds to 4. So if they're at 5 and they choose 3, you can choose 1. You'll only be able to choose 1. But that's the trick. You can always get to 4 to give them the next value. So it's what? It's not a multiple of 4. It's a multiple of 4 plus 1. Is that true? So 5 is 4 plus 1. 9 is 8 plus 1. 13 is 12 plus 1. So, yeah, okay. So I know there's going to be modulus involved in here somehow. I always have trouble with modulus. So I want to leave my opponent at a number that is a multiple of 4 plus 1. So what is that? So I could say, well, first of all, I think maybe I should say like if total, so right here, if total is mod 4 is 1. Hold on, is this right? Basically, I need to detect if I'm if I'm already at one of these bad numbers. So if I've been given whatever 17, it doesn't matter what I choose. So I might as well just go back to random. So that's this number. So this is the case where like I'm already at 5. Yeah, so 5 mod 4. So that's like 5 divided by 4, take the remainder, is 1, I think, if I remember my undergrad computer science lessons. Then it doesn't matter. Like I've already lost, so I might as well just choose randomly. Otherwise, so I'm not at one of these like magic losing numbers. I want to leave my my opponent at one of these numbers. So is it something dumb like this? Is it just like is it total? Let me write something and see how I feel. Equals total mod 4. Is it? Let's see. So if I'm at, I don't know, 7, then 7 mod 4 is 3. And yeah, that's the right number to choose, because 7 would leave me at 4. Okay, if I'm at 6, then 6 mod 4 is 2. And that's right, it would leave me at 4. Okay, let me double check if that's right. 6 mod 4 is 2. Yeah, okay. I'm thinking about this right. Yeah, all right. I think that might be right. I don't know, let's try. Let's just try. And I can get rid of some of these, so choice equals 1. I don't want that anymore, certainly not. Okay. So if, yeah, okay, that's just if hard mode. Okay. Let's just see what happens. I'm going to choose hard mode, and I've already lost at this point, right? So no matter what I choose here, the computer will give me 17, because 17 is one of those magic numbers. And did not. Oh, wait, no. Wait, what just happened? wait. Hold on. We were at 21. I subtracted 2. It's at 19. It subtracted 3. That's not right. Is it? No. Hold on. Let me think about this. Okay, something's messed up. So let's look at this. So if total, so I went 19. 19 mod 4 is 3, I think. 19 mod 4 is 3 indeed. Okay. So I'm not going to enter this. So choice equals 19 mod 4, which again is 3. And so that's not right. This value is not right. Is it 1 plus? So if I'm at 19, what should the computer choose at 19? It should choose 2. At this point, I want to get like a piece of paper out, but maybe I can do it in comments. So let's see. If I'm at, let's just try it, 19, what should the computer choose? The computer should choose 2 to leave me at 17. Yeah. If I'm at 18, the computer should choose 1. If they're at 20, they should choose 3. And if they're at 17, then they're screwed. So if they're at 17, then they should choose random, because that's this case. So 17 mod 4 is 1, right? 18 mod 4 is 2. 19 mod 4 is 3. 20 mod 4 is, wait, 0. Should this be 3 minus? 20 mod 4 is 0, so that would be 3. 19 mod 4 is 3. That'd be 0. All right, this is not right. Something's messed up. I'm just kind of adding random junk. So what's the pattern here? 20, 19, 18. Yeah, I need like a table is what I really need. So it's like number, man, this is gross. I should just get like a spreadsheet out or something. Whatever. Number, let's do this. Choice number mod 4, something like this. I wonder if it's like, it's actually mod 3 or something. It's gonna be something stupid. So 20 mod 4 is 0. 19 mod 4 is 3. 18 mod 4 is 2. 17 mod 4 is 1. Yeah. So how do I go from number to n mod 4 to choice? Or is it something like, let's do n mod 3. Let's just see. It's something, it's one of these. It's something like this. I don't have like a feel for mod, or like I maybe should. So, oh man, what's 20 mod 3 is 15, 18 is 2. 19 mod 3 is 1. Whoops. 18 mod 3 is 0. 17 mod 3 is 12. 15 is 2 again? Yeah, no, that makes sense. Okay, so can I get to choice from here? Can I add one? Plus 1, plus 1, plus 1. Doesn't matter. Yeah. This is right. Okay. So if I'm at 20, then I take 20 mod 3 to get 2. I add 1 to that. Okay. So it's actually this. Oh boy. It's getting gross, but I think this is right. Total mod 3 add 1, because we've already checked this case. Man, I have a feeling that I'm going to finish this up and I'm going to watch this video, and I'm going to, only after I publish it and start watching it again, I'm going to be like, oh no, this is totally wrong. Of course this won't work. And that's going to be embarrassing, but let's just see. All right, hard mode, activate. I'm at 21, therefore I should not be able to win. So nothing, no matter what I do here, the computer should always bring me to 17. Okay, that worked. Let's try all of them. Let's try that again. Cool. Yeah. Awesome. Oh wait, that was on easy mode. That was just chance. That's funny. Whatever. Hard mode, 17. Yeah, okay, so I think this is working. So let's just play a game. Hard mode, so no matter what I do here, it should take me to 17. Cool. Now from here, no matter what I do, it should take me to 13. It did not. Why? Why not? Oh dear. All right. This is annoying. This is so annoying. So I should have looked this up ahead of time, but I don't know. Part of the fun of these videos is not looking stuff up. So we were at 14. 14 mod 4 is not 1. Therefore, computer shows 14 mod 3 is 2 plus 1. It shows. It did what we told it to, but that's not right. Oh my god. All right, well, let's just keep going with our stupid table. And this is similar. No, it's not. Whatever. I'm getting annoyed. 16. If we're at 16, what should the computer choose? Or if the computer is at 16, what should it choose? It should put us at 13, right? 5, 9, 13, yeah. So it should choose 3. What is 16 mod 4 is 0. Well, this doesn't matter because I was barking up the wrong tree with that one. N mod 3, 16 mod 3 is, wait, 16 mod 3 is 1. 2. Oh yeah, we're at 16, not 14. Oh man, 15. What should the choice be? Choice should be 2. N mod 4, this one doesn't really matter, but just for fun, it is 3. Is that right? Yes, it is. And mod 3 is 0 here. And 14 is, it should choose 1 here. What's 14 mod 4 is 2. What's 14 mod 3 is 2. And 13 is our bad number. 13 doesn't matter. Choice is random again. Yeah, and this pattern works. 3, 2, 1, 3, 2, 1, okay. 13 mod 4 is 1. 13 mod 3 is 1 again. So what's happening here? Did I mess up something? All right, you know what we're gonna do? We're gonna do this. We're gonna check my math because I'm not at all confident in my ability to do mod in my head anymore. Oh man, I think I'm losing it. All right, let's do 20 mod 3 is, oh my god, too small. Is 2, I was right there. Let's just do it this way. 19 mod 3 is 1. Yeah. I was right. I was right. Yeah. 18, 0. 17 mod 3 is 2. Yeah, I was right on all of these. How dare. All right. So clearly something is not right. So this is not right. Or I can't get to the choice from here. Can I get to the choice from here? So is there a pattern here? 3, 0, 2, 3, 1, 2. 3, 0, 2, 3, 1, 2. There is a pattern, but it's not obvious to me. Is it? So I need to go from here, from N mod 4 maybe to choice. So it's like +3, -1, -1. What the heck? You know what? I might cheat. I might have to cheat. I've been staring at this too long. I'm pretty sure that somewhere in this Wikipedia article they give you this formula. Let me find it. Okay, what's this? Yeah. Okay, I don't understand any of that. Mod. mod k plus 1. What's k? K equals 3. Wait. Yeah, k equals 3 in our case. I don't know what this symbol means. Okay, that didn't help at all. Man. I know you're probably staring at this and you're saying like, oh, here, like it's obvious what the pattern is, but being on mic takes away like half my brain. So we take n mod 4, we get a number from it. I mean, I could, I know there's a number. I know there's a formula for it. I could just do an if statement though. I could say if n mod 4 is 0, choose 3. If n mod 4 is 3, choose 2. That doesn't feel right though. You know what? I'm gonna do some Googling. Game of Nim modulus. Yeah, sure. What's this? Yeah, it's funny. Here's what I was talking about earlier, where one way to model it is like with this tree. That's what they're talking about here. It's pretty cool. I should have looked at this ahead of time, maybe. Yeah, like do a little modular arithmetic in your head first. Yeah, that's exactly the trick. I'm just kind of clicking random stuff now, which is always a recipe for disaster. Like I said, maybe I should have looked this up ahead of time. Okay, you know what I'm going to do? I'm going to pause this video. I'm going to do some reading, and I'm going to be right back. All right. Through the power of time travel and video editing, yeah, it's been about half an hour of me staring at this for a while. And, well, good news and bad news. Bad news is I still don't really have a great pattern that is like just one-to-one mapping or anything like that. But the good news is I think I've started this long enough that I think I can do it. So I think that I found that the pattern is if I subtract 1 from n and then take mod 4, that's my choice. I haven't actually tested that out, and if it ends up not working, then I am just going to do a really dumb if statement. I've decided. In theory, I should have maybe looked this up ahead of time and did all the research and whatnot, but honestly, like my goal with these videos is not to, I don't know, like lecture. My goal with these videos is to show the real life process of coding, and this is what it looks like. It's a lot of banging your head against the desk sometimes, for better or worse, and it's fine. Here we are. Back in the code, I have said, all right, we're in hard mode. So if your total is already one of the like magic numbers, then you might as well just choose random value. So that's fine. Otherwise, let's see, I'm going to take the current total, I'm going to subtract 1 from it, and then I'm going to mod by 4. And that lets us convert, from these numbers from n mod 4 to the choice that we want. So if the current number is 20, then I want to choose 3. And the way I can do that is I can take 20 minus 1, which is 19, and then 19 mod 4 is 3. And that's how you get to the 3. And I've checked that at least the first few rounds of numbers make sense. So that's it. That's all I'm going to do. I'm going to hope that this works, and if not, then I'm going to just use stupid if statements, and that's totally fine too. All right, refresh. Let's see. So I'm at 21, and hard mode has been enabled. Now the computer should always go to 17. That's what the computer should do here. Okay, and they do. All right, now I'm at 17, so the computer should always take me to 13. And it does. Okay, the computer here should always take me to 9. And it does. Here, the computer should always take me to 5. And it does. All right. And here, the computer should always win. And it did. Cool. And so that's hard mode. So 17, 13, 9, 5, win. Cool. So it's actually impossible for the player to win on hard mode. Okay, and that's actually exactly what I would expect. Cool. So that worked actually. So maybe I can get rid of this table. So the trick here is to go from total, subtract 1 from it, and then mod 4. And that gets you the nice 1-to-1, 3-2-1 mapping for the correct choice. So all of that, like staring at stuff, didn't really actually do anything for me. I just had to think about it and fill out more of my table. I tried to do some more reading, but it only confused me more. So sometimes just filling out tables of choices can be helpful. I should probably use an editor that automatically formats my if statements for me, but well, I also never remember if I want this space there or not. Whatever, it doesn't matter. Anyway, okay. Where are we? What are we doing here? This was supposed to be like a nice little Sunday afternoon activity, and you know what? I guess it was. So here's what I'm wondering. I'm wondering if I can get rid of this. If I'm at 4, then I think that this will work. If I'm at 4 or below. So easy mode will just be completely random. How do we feel about this? I feel okay, I think. Maybe I'll hit backspace here. Maybe I'll hit backspace here. Does this work? So if it's hard mode, no, this won't work. This won't work. I'll need some logic here that prevents the easy mode from going off into negative land. But let's just check that this works. And I could probably reason about it, but my brain's kind of fried. So I'm just going to refresh. I'm going to go to hard mode, and I'm just going to get down to 5 and see if it does the right thing. So 9, this should take me down to 5. And now here we go. Cool. That worked. Okay. So I'm just going to do all of the numbers. In fact, I should read through the code to understand it, but I'm not feeling it. Does it do the right thing for 2? It does. Cool. And my guess is that it'll do the right thing for 3 too. 9, 5, and it 1. All right, cool. So that worked. So I can actually get away with not having that logic. All right, so the last thing I want to do here is make sure that random is that it doesn't ever go negative. So what do I want to do here? Here I'm just choosing a random number between 1 and 3, and I could just do like a maximum. Maybe that's what I'll do. I could maybe do something with this. Let me think about this. So if I'm at 4, then this is fine. Any of these numbers will work. If I'm at 3, then I don't want to be able to choose 3. If I'm at 2, then I shouldn't be able to choose 2 or 3. It should always be 1. So I could do an if statement here, like if I'm at 2, then always choose 1. It's kind of goofy. Let's just see how we feel. I'm going to start writing it and I'm going to see how we feel. If total equals 2, then choice equals 1. How do we feel about this? I feel pretty good about it. I feel fine. Okay. It's really funny to me, interesting to me, how much of coding is like feeling. It's subjective. Like, how does this solution feel? Like, how does it fit in your brain? Does it match your assumptions? I always think that's interesting. Anyway, if total equals what? If it equals 3, yeah, if it equals, oh my god, I can't type anymore. If total equals 3, then I want to choose either 1 or 2. So I could do like a coin flip, like check if math.random is less than 0.5, something like that, but whatever. So what do I want here? Do I just want 1 here? No. 2. Is this right? I think so. So this will be between 0 and 1.99999. Then I floor it, so it'll be 0 or 1. Plus 1 is 0 to 2. Okay. Good enough. This is fine. I'm like that dog with the fire all around me. Like this gross if statement, totally fine, totally great. I love it. But whatever, this will work maybe. Yeah. So what have I done here? I said if hard mode is checked, then we do the logic we just figured out. Otherwise, we check if it's 2 or 3 or not, and choose the random number based on that. All right, so let's just try easy mode a few times. Kind of annoying to have to deal with this delay, but oh well. Yeah, okay, I think I'm pretty convinced that nothing will break horribly. Let's maybe just run through a couple just to double check. Okay, cool. I could probably start my total off lower so I don't have to just sit here and click buttons randomly. Yeah, I haven't been paying attention to what these numbers actually are, so it's fine. Yeah, okay. Whatever, I think it's fine. And if not, then I'll correct it in the final code that I post. But I'm kind of getting, I'm ready to wrap this up. I think you're probably ready for me to wrap it up too. So let's maybe just recap for a minute. So I've used vanilla HTML, CSS, and JavaScript to code up a game of Nim. And there are actually many different things, many different games that are called the Game of Nim. I am specifically talking about a version of the game called, where is it? Probably called the Subtraction Game. I think it's this one, where you start with a number and you subtract and go back and forth. And the logic is either totally random with easy mode, I'm calling it, or it's using that trick of modulus to make sure that the human is stuck on these like losing numbers. So 5, 9, 13, 17, 21. These are all losing numbers. To maybe demonstrate that, maybe let's start out in easy mode so I can trick the computer into letting me give them a bad number. Yeah, here we go. So there, wait, I'm at 17. All right, hold on. All right, so through the power of random, they are actually playing a pretty good game here, but they'll slip up eventually. Maybe. Okay, there we go. I'm going to give them 5 because that will always make them lose. Because no matter what I do here, I will win. Well, no matter what they do here, I can win, I should say. Kind of still want that reset button to be at the top, but it's fine. All right, and here's a better example. So I'm going to play like a perfect game. So we're at 19, so I can get the computer or force the computer into these bad numbers. So I'm going to give them 17. Here I'm going to give them 13. And here I'm going to give them 9. And here I'm going to give them 5. And I've won now. So that's the logic that the computer follows in hard mode, which is this like kind of convoluted looking if statement here that uses the trick that took me like a half an hour of staring at a table of numbers to come up with, but total -1 mod 4 seems to do the trick. And circling back to the beginning of this video, like why I find this so interesting is like the random player, it makes sense, and that's probably how most like human players at least start out playing the game. And we talked about some of the other options for thinking about how to code this game. One would be like this Minimax algorithm. The other would be like that table of options for each number, what the choices were, and like learning over time and like adding and subtracting based on wins and losses. And that's, there's a whole lot of interesting things to talk about there. But all you need to code a straight up perfect game is this line of code. And there's something really interesting to me about that, or maybe even beautiful. And it's this line of code is not at all obvious. It took me a long time of staring at it to even get it here. And I don't think if you asked someone who had played 100 of these games kind of organically, I don't think they would be able to volunteer this pattern to you, even if they found the pattern of 1, 5, 9, 13, 17, 21, even if they found that through like pattern recognition or just reasoning about it, I still don't think they would think in terms of this. And one of the reasons I think that's interesting is it's kind of an example of like the different approaches to artificial intelligence. And I don't want to get too grandiose, but if you think back to like, I don't know, early airplanes, for hundreds or maybe even thousands of years, we couldn't figure out how to create an airplane because we kept looking at birds and we kept looking at like nature and trying to model our like artificial flight over natural flight. So a lot of like early airplanes have like flapping mechanisms and kind of goofy looking things like that. I mean, goofy in hindsight, but back in the day, they were looking at birds and saying like birds can fly, so we should fly like birds. And none of that worked until someone who's way smarter than me figured out like we should not be modeling it after birds. We should do something completely different. And that's how airplanes work. So with AI, people can get kind of obsessed over like modeling the human brain and doing things like neural networks and machine learning and all that stuff. And there's value to it, of course. There's interesting things there, but you can get a lot done with an if statement and some arithmetic. And this here plays a perfect game in a way that any of the other options, any of the more advanced options like this Minimax algorithm or just a full like traversal of the graph, they would not be as good as this single line of code. And I think that's really cool. I think it's really interesting. And you could go one level deeper here and to make this even harder. On hard mode, the human will never win hard mode. However, they will notice the pattern after enough time. Like they'll know, Like if you keep playing here, you'll recognize like, wait a second, this number's always 17. And this number is always going to be 13. And the next number is always going to be 9. And that can kind of give away the trick. So the human will actually learn the pattern because the computer is playing a perfect game. And eventually the human will, learn that they can't win. And they'll even be able to use the trick if they are not stuck at a losing number at the beginning. And so to make this a little trickier, what you could do is introduce just a little bit of randomness to it, so that even when we start, sometimes it does not start perfectly, and that will actually it'll make it harder for the human to see the trick. It'll make it harder for the human to realize that they can't win. And there's so many interesting things in that direction where there's a question of what you're optimizing for. Like, what are you trying to convince the player of? And giving them a chance sometimes will be more interesting than if the computer is just like super difficult. And it's this relatively simple game, subtracting 1, 2, or 3 from a number back and forth. It's pretty easy to explain. But it opens up all of these questions and all of these sort of interesting philosophical artificial intelligence balances. And I really find all of that stuff really interesting. So anyway, that's like why I chose this Game of Nim as my sort of whatever challenge today on this beautiful Sunday afternoon. All right, cool. So if you've watched this far, truly thank you. I really appreciate anyone who's stuck with me this long. And if you have, like, drop a hello in the comments. I'd love to hear from you. So from here, I'm going to post the code and stuff online, and I'll link to that in the description. But from here, there's so many things you could do. So you could explore the other forms of Nim. There are many other forms of Nim that, I don't know why, but many different games are called Nim. And some of them have similar properties, but they introduce some other interesting concepts and other interesting things. You could, instead of having like easy and hard mode, which is kind of random and perfect, you could also introduce a mode that uses Minimax, or something like Minimax. I think maybe Minimax is too grandiose a term for what I would do at first. Like, do a full traversal of the tree, for example. I think that would be doable. I think, write that algorithm and add that as a mode. I think that would be really cool. Or the other mode that I don't have a Wikipedia page for, but it would be the sort of array of different choices based on the numbers, and have the computer learn over time. And that would be super interesting as well. You could also make this prettier. I have maybe 10 lines of CSS in here somewhere, and it's fine. It gets the job done. I kind of wanted something kind of vanilla and simple looking, but you could make this look cooler. Add animations, add pictures, add whatever, add explosions when someone wins. I don't know. There's a lot you could do just in that direction, even if you don't get into the more algorithmic stuff. And like I said, if you do find any of this interesting, and if you do take this and run with it and remix it and make your own thing, I would love to see it. So come say hello on Happy Coding, come to happycoding.io, come to our forum, and I'd love to hear from you, or just drop a comment in the comment section of this video. Let's see. So from here, maybe I'll just play a game just kind of quietly, and let's play easy mode first, and I will try to win. So I'm at 14 and I want to take it down to 13, right? Yeah, kind of. I still don't love that that you have to scroll so much. It's fine. I might fix that later, but you know, the way I would do that is just put this thing in a div and put a max height on it, and then have the scroll bar be on the log itself. But whatever. This video's already long enough, and that's not, you know, super interesting to the overall problem. But anyway, that was playing easy mode. Let's play hard mode just to depress ourselves. Beautiful. Yeah, you know what? I can't deal with it. That's like, it's just going off the edge, and that's so annoying. So I am going to fix that real quick. Promise. Last thing. What do I want to do? I want to do this. Where do I want to put that? I want to put that in where I log the wins. So it's either in play computer turn. So I log that, and I also want to do this inner text plus equals. Let's see. So I say U1 here, U1, let's say U here instead, subtracts, U subtracts, U subtract, U subtracted, yeah, whatever, good enough. Whoops. Cool, yeah, that's so much better. And let me play hard mode just to check that the computer winning does the right thing. Cool, perfect. That's fine. I think the rest is fairly obvious. You know, if you want to look for a reset button, you'll find it. Good enough. So I'm calling that done. And you know, everything I just said, copy paste that, pretend that it's at the end here. But yeah, I'm tempted to fiddle. Do I put like a, can I put like a HR here? How's that look? I don't want that there. I want that here. Nah, I don't like it. All right, I'm done fiddling. That's it. I'm calling this done. Good job, everybody. If you stuck with me, please leave a comment. I'd love to hear from you. But I really appreciate everyone watching. And yeah, I thought I love this game just because of how simple it is at the very beginning, but it introduces all of these really interesting concepts. So if you want to chat about that anytime, either leave a comment or come to Happy Coding, come to our forum and stuff. But for now, I will simply say have a great day. Thank you so much for watching. And as always, happy coding.